Hi friends, in this problem we are given that A1, A2, A3 until AN they are in arithmetic progression. We have to prove 1 by root A1 plus root A2 plus 1 by root A2 plus root A3 plus until 1 by root AN minus 1 plus root AN. This is actually equal to n minus 1 by root A1 plus root AN. Right. This looks little clumsy, but in fact it is very straightforward. Whenever we are given certain terms in arithmetic progression, so we should try to use the difference of these two terms. For example, a2 minus a1, a3 minus a2, or an minus 1, etc. The difference is constant. We should try to use that. Now, but in this problem, in these terms, there is no a2 minus a1 or a3 minus a2. Right. But we have to convert this. We have to convert this into that format so that it becomes easy for us. How do we convert this? Because we can rationalize the denominators, right? We can rationalize the denominators. These are not rational denominators. We can rationalize them and convert them. Let's see how. 1 by root a1 plus a2, we can multiply on both sides, on numerator and denominator with root a2 minus root a1 by root a2 minus root a1, right? This is how we rationalize, right? If we multiply this term with this, then what we get? In the numerator we'll get root a2 minus root a1, and denominator we get a plus b into a minus b, a square minus b square, that is a2 minus a1. Right, here we have converted now. Right, a2 minus a1. This is what we wanted. A2 minus a1 is constant, which is actually d. So somehow the denominator we have converted to constant. Similarly, this one also we will convert. The denominator will become a3 minus a2. Right, and numerator will become root a3 minus root a2. Right. Similarly, we can convert everything. So see, if you see all the denominators, a2 minus a1, a3 minus a2, a4 minus a3, they are all same because these are consecutive terms and the difference is always same, which is d, the common difference between two terms. Right. Then this will become the same s, the same summation. This whatever left hand side will become root of a2 minus root of a1 by a2 minus a1 and root of a3 minus root of a2 by a3 minus a2, etc. etc. Right. Now, the numerators might be different, but the denominators are all same. a2 minus a1 is equal to a3 minus a2 equal to whatever, everything is equal to d. Right. Now, because it is the denominator is all same, we can directly add numerators also. If you see this root a2 minus a1, a3 minus a2, a4 minus a3, these all things will cancel out. For example, a2 and a2 will cancel out. Similarly, a3 and a3 will cancel out. Everything will cancel out. What will be left? We will be left with the first a1 and the last an. First root of a1 and last root of an will be left with root of an minus root of a1. Remaining all middle ones will cancel. By the difference is d. Right. But still, we have to prove, we have to bring these roots again in the denominator. Right. To get that, what we do? Again, let's multiply with the conjugates again. Root this, let us multiply this one with root an plus root a1. Root a1. Right. Then the numerator will become an minus a1, but denominator will become root an plus root a1 into d. But what is an minus a1? Which is a, we already know an is equal to a1 plus n minus 1 into d, right? The nth term is equal to a1 plus n minus 1 into d, right? So that's why an minus a1 is equal to n minus 1 into d. So this d and this d will cancel out, and we will be left with n minus 1 by root a1 plus root an, which is what we wanted to prove. Right. It is simple manipulation by rationalizing the denominators and keeping in view that the differences are all same. Okay, guys. Thank you.